If we have 120 kilogram mass with some unknown force, F, which might well be a function of t, we know the initial velocity of the object to be 6 meters per second and the final velocity to be 14 meters per second over a time interval of 0.4 seconds. That is, in the 0.4 second time interval, velocity increases from 6 meters per second to 14 meters per second. And we want to find what average force is required. Well, again, we can analyze the motion. We see that the average acceleration is the change in velocity, 14 meters per second minus 6 meters per second, divided by 0.4 seconds, giving us an 8 meter per second change divided by a 0.4 second time interval, therefore a 20 meter per second squared average acceleration, and that the average force is then the mass times the average acceleration, 120 kilograms times the 20 meters per second squared, or 2,400 newtons. Now, using impulse momentum, the impulse is equal to the change in momentum. The change in momentum is the 120 newtons times 14 meters per second, which is the final momentum, mass times velocity, minus the mass times the initial velocity, 120 kilograms times 6 meters per second, which equals 960 kilogram meters per second. The impulse is therefore average force times delta t, equal to the change in mass times velocity. Since we know the delta t, we're going to be able to solve for the average force very easily. Average force is change in mv divided by delta t, which is our 960 kilogram meter per second change in mv, divided by the 0.4 seconds, or 2,400 kilogram meters per second squared. And a kilogram meter per second squared is our unit of force, is a newton. So I should note that that equals 2,400 newtons and agrees with our previous result.